Okay, today's lesson is going to be 4.7.4. But first, I'm looking at the end of last night's worksheet, 4.7.3. Ready? Ready? So, I can see a few things wrong. Cell phones, they should be gone. There's a couple of them out. Only a couple. All right, good. So, I'm looking at 22. Look at that problem, please. Now, to begin with, where do you start? You start on the inside. Did I do 22 for you the other day? Okay, then let me help you with it right now. Why is it weird compared to all the other problems above it, like all the easy ones that were up there are relatively easy ones? What's different about 22? Come on, you can do this. One of these things is not like the others. What's different about this? Yes. Okay, we didn't do many tangents before this. That's true. But that's not what I was going for. Tangent's just a normal function. Yes? Yes. It's not a familiar triangle. In other words, the 2, 7, 5.5 triangle is not one we have memorized, right? So these sides right here are a little weird. All right, so I need to rewrite this over on my smartboard because this isn't working. Tan on the outside, inverse tan of -2/7. So tangent of inverse tangent of -2/7. Okay, where do we start? Simple. Inside. If we start on the inside, then we make a picture for this. You always make a picture. Yes? Okay, you're right that it doesn't necessarily mean that 2 is negative. We've never said that the top number has to be negative or the bottom number has to be negative. We look at the triangle and we see. Do you get, though, that it matters that this is negative, therefore we have to pick the right quadrant to be in? Doesn't matter which is negative. What matters is that it is negative. All students take calc means that tangent is positive here and here. I'm crossing them off because we know tangent's negative because, see, it says it right there as a negative in the problem. Okay, so now, of the two places that are left, we can narrow it down because inverse tangent is only allowed in here, so therefore it can't be there. Do you get where you have to draw the triangle now? And now that will force you to label one of the sides as negative. Can you see which side is negative? All right, so therefore that side has to be negative. Now tangent is opposite over adjacent. The opposite side from this angle's perspective is going to be this one, and that's 2, and the adjacent is 7, and which one's negative? The 2. That's how you can tell which one's negative. Okay, now I got to figure out the rest of the answer. Normally, when they do a little power like this, they're saying, what angle is it? They've already given me the sides. They're asking for an angle. That means, tell me an angle answer. Well, I don't know what angle this is. So, you can't give them something that you can't do. You aren't expected to figure out that that's like negative, 3 pi over, 13 or whatever it is. You don't know what angle that is, and you never will, and that's okay. So you got the triangle drawn and labeled, and if you knew what the angle was, great, but we don't. So we just stop right there. And then we use this tangent on the drawing we just made. So tangent on this drawing we just made. Now, am I breaking any rules? No, tangent can be anywhere. You know what I'm talking about? Inverse tangent can only be here to here, but regular tangent, like this one, can be anywhere. So I can't break a rule by doing that, unless they made me do it on this spot right here. Do you remember that tangent's undefined right there? Because it's the spot 0, 1, and it's y over x, and therefore it's 1 over 0. And at this spot right here, it's also undefined. But we're not there. We're in a spot where it's okay. So all you're doing here is verifying, yep, it's okay. I'm not breaking any rules. So if I'm not breaking any rules, and this kind wants me to give it a sides answer, then it's the sides, which are -2 and 7, -2/7. So it's the same thing as was right there. I will tell you that about 2/3 of the time, you could have just canceled this and this and got this answer. But you have to check first to make sure that you aren't breaking any rules by doing that. I want to give you an example of that. Cosine, you can't always trust this. Cosine of 3 pi over 2, and then we're going to go to the outside and do the inverse cosine of that. Everybody write this one down. This is a good, do you really get this question? So first of all, find 3 pi over 2 and do cosine of it. Remember that this inverse here, you shouldn't even be thinking about this until you're all done on the inside. And there's only one 3 pi over 2. Don't get confused like, oh, there's two answers for this. No, there's only one place that is 3 pi over 2. And then cosine of it is sides. The answer to this is sides, because they already gave me the angle. Then I need to get sides for my answer. But it's not a triangle, you say. You're right, it's not a triangle. Can't make a triangle at 3 pi over 2. So then you got to do cosine, and remember that sine's y. What's cosine? The x. So hopefully you have drawn this, and you've said, okay, 3 pi over 2, that's here. And then that spot right there is 0, -1. And cosine of a spot is its x. Cosine is x, so it's 0. So this whole thing, the answer is 0. And just be careful now. Is it 0 degrees or is it 0 like side ratio? Side ratio is 0, because the degrees was 270 or 3 pi over 2. This is not a degree answer. This is a 0. That's a side answer. It's like 0 over 1. Or just 0, whichever you want to say it. Okay, now I can bring in and do the outside part. Because now, do you get the problem has boiled down to inverse cosine of 0. That's my new problem. Do I use the same picture? No, don't use the same picture. Remember, if you're done on the inside, then you're done. And I got an answer? Yup, I got an answer. The answer is 0, so now I move on and do this new problem. On the last problem we did, we used the same picture. Why? Because we couldn't figure out the angle. If we didn't, because you can't get the answer for this one, we just use the same picture when you finish the problem. On this kind, I can get the answer. The answer was 0. Now you've got to do inverse cosine of 0. So first thing, rewrite. That means cosine of some angle is 0 over 1. That reminds you, you're not doing 0 degrees. Cosine of some angle. See how this is saying, please give me an angle? A little -1 there. So then, once again, it's not a triangle, so I must be in one of these 4 spots. But it's a different spot than last time. That's why I said you got to redo this drawing, because I think a lot of you are assuming, oh, it's going to be the same spot right here. Nope, it's not. Cosine is x, right? So the question is, where is x equal to 0? Well, isn't this a spot where x equals 0? Yeah, but it's not allowed down there. Know why? Because we're doing an inverse cosine problem, and it's only allowed from here to here. So I can't be anywhere down here, including the axis. Okay? Now, within the area where I'm allowed to be, now is there any answer? Yeah, there's one spot where x is 0, and it's at this spot right here. 0, 1. That's one spot where x is 0. So remember, if it's got a little -1 here, it's saying, give me an angle. So what's the angle? Pi over 2. Do you get why people who just try to go cancel, cancel will fail? Look back at the original problem. We know the answer now is pi over 2, right? Go back to the original problem. There. And I was undoing stuff off of this. Okay, I'm going to just go like this. Clean it up this way. Nope, not that. This part needs to move. Having some technical difficulty with the smartboard today. It's a little grouchy. Okay. So here's my original problem. We know the answer now was pi over 2. Danger, kids like to go like this and think it's 3 pi over 2. It's not. Because 3 pi over 2 is an area that wouldn't be legal. Okay. The whole point of yesterday's worksheet at the end was trying to show you that you don't always know the sides, you don't always know the angles, but you can still do the problems. So let me give you one more like that. Sine, you aren't going to know this angle. Negative 7 pi over 8. You know where 8/8 of a pi would be. Negative 7/8. And then we're going to do the inverse sine of that. But you start on the inside. You draw yourself a picture. If you can't figure out the angle or the sides, we know the angle, sorry. If you can't figure out the sides in this case, which you won't be able to, unless you got to go to a calculator and use like a complicated trig to do it, you don't need to, because you're not going to have a calculator. So draw me the picture and then tell me what the final answer is on this one. Turn it my way when you've got it. And then you can turn it back towards yourself once I've checked it. Remember, when you're all done, you finish on the outside of these problems, right? When you're all done with this problem, it's saying, how many degrees is it? Or how many radians is it? This says, I want an angle. It wants an angle. If you've got the answer, turn it my way. Okay, there's a lot of really lost people, so let me show you. First of all, where is negative 7/8 pi? Well, we know it's negative, so it's going this way, right? And how far do I stop? Well, 8/8 pi would be at pi. So 7/8 pi is like somewhere in the neighborhood of here. Okay, so there's my angle. This big angle right there. So of course we use the reference angle and we go like this. And I told you this isn't one you would know, so therefore you don't know what the side lengths are on this guy. But you know it's 7/8 pi. There we go. That's all you know. So you don't have to do any more with that. Now it's done. You've done all you can. If we knew what the side lengths were, we'd use them, but we don't. So now we got to go inverse sine of that. And we don't know what that is. We don't know what the sides are, so we use the same picture. Now, what's the problem with doing inverse sine on this triangle? You can't do inverse sine over there. Do you get inverse sines only allowed from here to here? It touches, actually, because it can touch both negative pi over 2 and pi over 2. So since inverse sine is only allowed over there, remember me warning you, if you're ever trying to do one over here, you're not doing it right? Inverse sines can't be over there. So therefore, there is no answer. It's no solution. All right, one more. Wait, sorry, I got my inverse in the wrong spot. There we go. Start on the inside. When you've got the answer, turn it my way. So hopefully your first step was to rewrite it. If you haven't already rewritten it, rewrite it. You go, okay, I got to be cosine of some angle is 2 over 1. How many people got that far? Okay, good. So now what? Cosine's adjacent over hypotenuse, right? Tell me what's wrong with this. Not possible. Is it even one of those quadrantals? Quadrantals are either ones or zeros, right? Or negative 1, I guess you could say. But it can't be 2. No solution. There's another reason why. Think about it. It's asking you for the angle where cosine hits 2. When does cosine hit 2? Cosine never hits 2. What's the highest cosine ever gets? 1. It's asking what angle, with the angles are the things down here, what angle would it finally hit 2 on? It never will hit 2. It goes up and hits 1, it comes back down again. So, no solution. All right. So the moral for the story for today is there's a lot of problems on today's worksheet, the new worksheet, which are going to be no solution. Not all of them, of course. Sometimes there is a solution. So this is one of the trickiest parts about inverse trig, is knowing when you can and can't get an answer. Let's see if I can find the worksheet for today. All right, this is the old worksheet. I'm going to find the new worksheet, 4.7.4. There we go. Everybody find 4.7.4. Get it up on your screen so that we can do some of these together. Now the cool part is that if you don't know, if you can't answer the question, then it's just about will it work or not? Is it going to crash or not? Do you get that on this one, the first one, they would want you to give them an angle for this in the middle? I wish I could transfer that to my other page. I think I can. It's just going to take me a minute. Tangent of inverse sine of 4/5. First step, rewrite. Sine of theta is 4/5. Next step, realize, okay, what does that mean? It wants the angle to be 4/5. When you're drawing it, inverse sine's only allowed from here to here. So that's out and that's out. Sine's positive 4/5. That means that's out. You get where it has to be drawn? Okay, so I'm drawing it. Sine's opposite over hypotenuse, 4, 5. And then, do you have the triangles memorized, the right triangles? I hope you have this one memorized. What's the other side? 3. Okay, so it's 3, 4, 5 triangles. So there we go. Now, do you know what angle that is? No. And don't expect that you have to, like, figure it out. You could if you had a calculator, but not without the calculator. So, if you can't find the angle, then don't find the angle. But then, in those cases, you say, okay, I'm done with the inside part. Now what am I supposed to do? Tangent. And then you have to use the triangle you've already drawn. So, what's the tangent on this guy? TOA, opposite over adjacent. Tangent is not just a 4. Try again. 4 over 3. Tangent within this triangle, and using that reference angle, tangent is 4 over 3. 4/3 is the answer. A lot of people ask me, how do you write these answers? Think about this. This is a normal trig function, and therefore you get sides when you're done. It's just one side over another side. That's it. You don't have to write anything else, just those sides. If on the outside it had a little -1 like this, then it wants an angle, which we should always do in radians. Okay. So there, that was your first one. That's problem 1 on the worksheet. The answer is 4/3. All right, let's see if we can do a few more here. Let's do number 5. Tangent of arc cos of -5/13. Negative, what was it again? Thank you, 5/13. Okay, so I start on the inside. I rewrite it. Cosine of some angle is -5/13. That reminds me, trying to find the angle. I already know, I'm probably not going to know the angle because that's not one of the big two triangles that I have memorized, and it's not a quadrantal either. So probably won't know the angle, but I'll be able to use the picture I draw to answer the question. So now, where is inverse cosine allowed? A, S, T, or C? A and S is where inverse cosine is allowed, up in here. Okay, quadrants 1 and 2. And then if we cancel those off, then it helps to narrow it down. And, oh, cosine's negative. Can't be here. Now I know it has to be here. And then cosine is adjacent over hypotenuse. The adjacent's -5 and the hypotenuse is 13. Do you have this triangle memorized? The 5-something 13? 12. Now, if you didn't have it memorized, I have showed you how to do this. You go square root of this squared and this squared, which is 169 and 25, and do I add them or subtract them on this kind? Subtract, so it would be 169 minus 25. If you hadn't already memorized that it was 144 and therefore 12, the 5, 12, 13 triangle is a common one. A lot of people know that one. 3, 4, 5, and 5, 12, 13. Those are the two biggies I would say you should memorize. They come up on the ACTs and stuff a lot. So again, the 3, 4, 5 right triangles, I think most of you knew that one. 5, 12, 13 is another biggie. Okay, so anyway, this one comes out to 144, and square root of 144 is 12. So that side's 12. Why did I care? Because I'm doing the tangent, and to do tangent of this angle, I need the opposite over the hypotenuse. Oh no, tangent's opposite over adjacent. 12 over -5. Does it matter where I put the negative? No. I put the negative on top if I wanted to, but I just want to keep it stuck on the 5 because that's the one that's actually negative. And does it make sense? I would always ask myself that at the end. They wanted sides. See, there's no -1, which would imply they wanted an angle. They want sides. I gave them sides. All right. Let's try another one. Why don't you pick one that you think looks hard? Even look intimidating to you to start with? All right. It is the last one, so a lot of times people hit on that. But what's special about it that's kind of weird? There's something different about it than all the others. It has a 3x on the inside. You're right. All right. So let's try to handle this one. Well, we'll start on the inside. So it's sine of arc cosine 3x. Sine of arc cosine of 3x. Okay. So I'm focused in on here. Rewrite it. Cosine of some angle is 3x. Now, would you agree I want to find the angle and I already have the sides? Okay, so I'm going to put this over 1. Okay, so now I'm going to draw my picture. This is an inverse cosine problem, so I'm only allowed to be here to here. You see how important those were? I told you a while ago you're going to use those a lot. Okay, inverse cosine's only allowed there to there. And now, how about the other restriction? Cosine, can I tell if cosine's positive or not? No, I can't tell if it's positive or negative. Okay, so there could be two possibilities for this thing. Now, don't overstress your brain on that then. We're just going to pick one. I'm going to draw it here. Always keep it simpler if you can. There. Now, cosine of that, adjacent over hypotenuse. The adjacent side is 3x. The hypotenuse side is 1. Can you still figure out the other side? Oh, yes, you can. Square root of, because it's a right triangle, right? Square root of 1 squared and 3x squared. 1 squared is 1. 3x squared would be 9x squared. Yep. So now I have a 1 and a 9x squared. Should I add them or subtract them? Subtract them. And which one's bigger? The 1 is bigger because it's the hypotenuse, right? 1 minus 3x quantity squared means 9x squared. That other side, it's got to be 1 minus 9x squared. Okay, remember me saying that you oftentimes won't get the angle? Well, you really don't know the angle on this one. So we can stop. We're done on the inside. Now, what is the sine of that triangle I just drew? It's an easy question. When you get to the end, if you've labeled your triangle well, it's easy. Sine is opposite over hypotenuse, right? So, what's the opposite side? That icky thing over the hypotenuse, which is 1. So, the final answer is just that over 1, so it's just that. Square root of 1 minus 9x squared. All right. Precalc is stepping up. Are you? You have to decide if you're serious about this class, because these next few weeks it's going to get harder, a little more abstract. It's not impossible. I think you can handle that, but that's probably the hard thing for today is that. Now I want to see how many of you stepped up and did your homework last night. So that's all I have for the video for today.